All right. Thank you very much for being here today. I know that we've seen a lot of amazing things in AI. The fact that it can generate images that are so realistic that it can fool you, or it can answer questions with amazing detail that you thought another human is actually answering them and listening to your questions. So for today, we'd like to know, how is this kind of technology going to be affecting AI? And I'm very happy to have our panel with us to help us give a very nice and rich diversity of the applications throughout. I'd like to start with Tingfang Ji. He's our Vice President of Engineering. Why don't you come up? Thank you. He is with wireless R&D. He leads our flagship 5G NR research project that looks at standardization and design, as well as prototyping with experimental macro network and other research that leads towards long-term 6G. So thank you for being with us this morning.
Thank you.
I'd like to introduce our next panelist. So this is Dr. Xiaoxia Zhang. So she's a Senior Director of Technology here at also with Wireless R&D. She leads the industrial projects focused on Industrial IoT and also bringing 5G technologies to unlicensed and shared spectrum. Her team also works on system design as well as prototyping, evaluation, and standardization. So thank you, Xiaoxia.
Thank you.
Why don't you, I can have you sit right there. Yeah, thank you. And then Frances Chen, very happy to also have with us she's a Director of Product Management for our 5G modem-RF products. She works closely with our customers as well as our ecosystem partners so that they can design the company roadmap, understand the product plans and the strategies overall. And then she works closely with our engineering teams to deliver on those.
That's right. Thank you.
Thank you. So thank you again for joining us this morning.
Thank you, Joseph.
All right, so what I'll do just to start us off is give a little bit of can you start the timer? Sorry to interrupt. Yeah, so what I'd like to do is just give you an idea of AI research at Qualcomm. So much of like what you've seen earlier, Qualcomm is really dedicated to making sure that we can make AI ubiquitous. We can have it everywhere in all of our applications, have it scale. And three important aspects to that are making sure that it's power efficient, that we can actually learn on the edge, so we can adapt models to the data that is being exposed to, as well as can we do learning efficiently, so that we can very quickly adapt, and that will save in power and also make the applications happen more actively. Now, when we do this, we can be able to also build a platform that scales AI, and we can go to different industries, different segments, and also cover the core tasks of AI, like perception and reasoning, and take actions from those. So AI research at Qualcomm is very holistic. It's very natural to think about applications, like fingerprint technology or looking at video enhancement. I think we all have seen how amazing camera enhancements are. They know the context of what's in the image, and they do the right enhancements for them. Now, coming to this, it's important to think, what are the fundamentals in AI that are happening, and how should the research evolve and track that? Because in some cases, like in generative modeling, deep generative modeling is a very fundamental part of AI research, where these images that fool you, how they're generated, that technology behind it, how can we look and understand that and innovate better so that we can take that back and for instance, can that affect video compression? Or self-supervised learning. This is a very complicated technique where essentially you're just trying to train networks without having given any label or any other annotation. And that really enables learning on the edge, because then we can continuously adapt models to what's happening in the scenario, continuously or at certain events. So these fundamentals help to bring our applications and improve them. Now, looking together at everything, it's important to understand that once we make these applications and these fundamentals better, we still have to bring them to the edge. And so platform research is a very important topic across the board for Qualcomm and AI research. And this can span many things. Like hardware design is a very natural thing that people think about, but even the software co-design, understanding how are you going to take this model, this description of a neural network, and execute it efficiently, make sure you save power, you do the right things, you keep the hardware always active. And also, what are the tools? Because in this particular space, we want a lot of developers to be able to just deploy their models on efficient accelerators and focus on their application and not have to worry about exactly how everything is running. So there's a lot of focus and development of putting these things together. And holistically, this is how you can see that we look at AI research at the company. Lastly, before we go very specifically into the topic of wireless, it's important to see that this full stack look at AI research at Qualcomm gets realized in many other ways, and it ranges from model quantization. This is we've been doing this for several years, where academic leading conferences, we have papers, but at the same time, that technology gets brought into an open source toolkit that can really help developers be able to use these techniques. On-device learning is a very important one, being able to adapt the model at the edge to deal with outliers, and also building a federated learning framework on mobile, the first ever that we can actually develop and let people experiment with on mobile. Video super resolution. This is another example where images, we can look to improve the quality using AI to upsample and do it at such a rate that we can keep up with very high frame rate video and high resolution like 4K. And then finally, neural video compression. This is as I said earlier, this way of harnessing this technology of generating these really photorealistic images. Can we actually use that to get a better compression technique that we can deploy on an AI accelerator at the mobile or in the cloud? So with that, this gives you kind of a picture of the AI research, and I'll kind of go into our panel so that we can look more in detail on wireless. So let me start with Tingfang here. So I kindly asked for each of them to help illustrate these and provide us with the slides that we can talk to. And I'll start with Tingfang and ask you, so how do you see AI for 5G generally affecting?
Yeah, so AI is a very powerful tool. And Zhang has already talked about it. Actually, AI is now considered one of the tools that 3GPP, or the standard defining body, is trying to use to design the air interface. But why do we need it? So that's actually, you need both domain knowledge and the AI experts like Joseph to design the AI-based air interface. There are a lot of problems in wireless that really you can just solve it with your fundamental understanding of the wireless system and our hands-on implementation. But at the same time, there are a few wireless challenges that has always been eluding us, for the designers. The biggest problem is we call it the hard-to-model problem. So we design a system always by assuming there's certain underlying model. One of the examples is wireless channels, right? So there's evolution of this channel in the last 30 years. We have better and better understanding of the channel. Then we apply information theory, communication theory to solve the problem. But the model is never perfect. So what's going to happen is AI machine learning, which is very good at cranking this data, which is very good at extracting model from the data you observe. So we're going to use that to help us to do the next level of wireless design. So yeah, so this is super exciting, but there's no guarantee yet. We see some hints of hope, but I cannot say that guarantee that I'm going to double, triple the spectral efficiency of the system with machine learning yet. But it's a very powerful tool, and we still have a few years, in my opinion, because 6G really comes in 2030, right? That's when it's actually implemented. I think for the wireless experts and the machine learning experts, we need to work together, and hopefully we bring in the next generation of AI-based air interface.
Great. I think what would be nice too is, since you lead a group that also has an experimental macro network, you could maybe tell us a little bit about how we're actually proving these out in the field and testing these out.
Yeah, thank you, Joseph, for mentioning that. Actually, we're also building prototypes. So last MWC, a couple months ago, hopefully some of you actually visited our booth. We actually had this, we ripped out the channel prediction part of the standards. We still have a spec compliant system, but ripped out one part of it and replaced it with a real-time cross-node machine learning-based CSF, channel state feedback. So with those components, we implemented on our AI100 on the network side. That's a chip we offer, and Hexagon on our, on our UE, on our mobile, we built a real-time machine learning-based channel state feedback system. So yeah, so we have seen really good performance, and next year we're going to come back and further improve it. At the same time, we are showing this to the standards body to let them know the feasibility of actually implementing this in a real-time system.
Great. Thank you for painting that picture. So let me talk with Xiaoxia here. So can you tell us about how do you see AI affecting industrial applications and the aspects that your team works on?
Yeah, thank you, Joseph. I'm actually very excited to be here to talk about with 5G and AI to transform Industry 4.0. So as we know that one of the key features for Industry 4.0 is to cut the wire and replace with the wireless. So with this wireless, we can enable the connectivity with massive amount of devices so that we can get a better data analytics with more and more data, and that allows us to have better system operation. So for example, for system upgrade, system reconfiguration, and so on and so forth. But of course, when you cut wire, you still have to maintain all the KPIs, the key performance indicators, as required by the industrial applications. So some examples of the requirement are this ultra reliability and low latency data communication, or people typically called so-called 6-9 reliability requirement. And the other example would be the precise indoor positioning, where people are basically requiring centimeter level accuracy across the board, even in the challenging scenarios. So we have done research experiment to show that, okay, actually with 5G and AI, even in a challenging indoor environment with industrial setting, so with lots of multipath non-line of sight, we are still able to meet that stringent requirement. So this can only be available or possible with the AI-assisted 5G connectivity. So actually,
thank you. I wanted to follow up because it was, when John talked about these new services like positioning coming in, and you just mentioned about AI making positioning better. Can you say a little bit more about what is the angle that AI is providing to actually improve that?
Yeah, thank you for the question. So traditionally, we know that if we rely on the typical wireless signal processing for positioning, typically people are relying on either angle information or the timing information. So for sub-6 deployment in the indoor, typically we were not able to have enough number of antennas. So that means the angle information will not be able to provide precise positioning information. And then for the time of flight, oftentimes it's more vulnerable when we cannot detect the first arrival path because there are lots of multipaths, and then all the first arrival path is blocked by the environment. So in here we played with basically the machine learning assisted RF fingerprinting, where we actually train our neural network with the environment which has a very heavy multipath and non-line of sight. So because the neural network captured that environment, so next time when we make a new channel measurement, we can still infer the very good location information.
Okay, exciting. That's cool to see. I'll come back to some of these later. I want to also, let's come to Francis. So we've been seeing a lot, as early as MWC, this AI-enabled modem. Can you tell us a little bit more about this?
Yeah, thanks for that question. Earlier this year, Qualcomm announced X70, which is the world's first modem-RF system, has a 5G AI process in it. So it is also the first time Qualcomm using AI in the modem design. So we developed features such as channel state feedback. And with AI technique, we can see across board, like UE throughput increase, especially at edge of cell. So at cell edge, we saw up to 26% downlink throughput increase for a pedestrian type of traffic under sub-6. Another example is millimeter wave beam management. AI algorithm predicts beam movement, so we can better redirect or focus beam. That essentially extends millimeter wave link capacity up to 20% in dense urban area. It also boosts like millimeter wave link robustness, especially in the indoor scenarios. In order to improve UE, like a mobility experience, we developed a modem algorithm to detect and mitigate some undesirable UE behaviors, such as ping pong between cells. Those are part of our like smart network selection. Not only on the baseband, but also in RF, AI-based antenna tuning algorithm optimize radiation efficiency on every device. So we basically train network model to recognize like a human and device interaction. So we can reconfigure and redirect antenna with accuracy and speed. So imagine like if you're a user who's playing a mobile game or downloading a movie or uploading video clips to TikTok server, for example, a higher throughput, a better link coverage, a longer battery power, and good mobility experience. All of those are highly desirable. So essentially, we're using AI technology to improve some key performance indicators in wireless communication.
Great. You know, just to follow up, I think a lot of people may have this sentiment that AI is very power hungry. You think of servers that are training and very high wattages for these. And now when we see the engine is actually in the modem in an industry, in a use case that's very power sensitive.
Right.
How do you feel that AI has evolved now, that at least within our technology, that we can actually now think about deploying these with our wireless connectivity?
Yeah, that's where years of research come into play, right? Qualcomm have invested many years on the AI research, especially edge AI. Research areas such as quantization and compression, those are instrumental to the commercialization of the AI technology. Without sacrificing accuracy, we improve power efficiency and reduce memory print. They have a direct impact on the device cost and power consumption, right? So I think without a solid research foundation, we could not achieve what we have done so far.
Okay, that's reassuring. Okay, let me open this up to more panel questions across all of you, and I'll feel free to jump in as you want, but maybe I'll start some. So one question I wanted to ask as we look more at 5G and AI and 5G and different applications in the communication system design. How do you see AI, continuing further? Do you actually see more of a black box now with more things being designed from just data-driven models? Maybe I can let Tingfang answer first.
Yeah. So black box type of approach can only take you so far. I think people have been throwing AI at all the problems. Someone, for example, want to use AI to design a channel coding. I don't know, since you're in the technical session, I'm going to throw in all the technical jargons at you guys. So yeah, like LDPC code, polar code, people are saying like, hey, can I just throw AI at it and design a better code? Doesn't work. So the complexity is just so high, the dimensionality is so high. It's really, you need to sort of understand the communication systems, go down to the inner blocks, and the easiest way is to use AI to, optimize some of the parameters based on the data. You could actually uncover many things that you haven't thought about. So one thing we realized from AI is you can use it for design, but it's also, although you cannot explain how it discovered the problem, but many cases, AI actually find you the corner cases that you haven't thought about before. The data is revealing the weakness in your design. So yeah, using AI is really like you said, the black box approach, people are trying it, but it's typically not very successful. We really need to get into the gut of the problem and have fundamental understanding.
Yeah.
Yeah, anything you'd like to add,
Okay.
please?
Yeah, maybe I can add a bit more on top of what Tingfang said. So how to basically combine the domain expertise with AI together. So one typical challenge what we are facing is that how do we keep updating the neural network because the environment change, as an example of the precise positioning by using the RF-based RF fingerprinting. So with the domain knowledge, one way what we could do, as we are demonstrating, is that we can use a classical signal processing, and then we use those good samples where we have very good accuracy from the positioning, and we can use those data to augment the data set we have to keep updating our neural network online. So this allows us to have the neural network tracking the environmental change, because otherwise those data collection, every time we don't even know when the environment is going to change. So this, by combining domain knowledge together with AI, so we're able to make this technology more realistic for the actual deployment.
Yeah, I just want to summarize. I think both panelists said very well. The big trend is more AI will be involved in the wireless system design. However, we still need people with domain knowledge and AI knowledge to be participating in this process. I think people with domain knowledge will make the learning process more efficient and faster. Like compare somebody who's new to this field, I think Qualcomm has a big advantage for having a very strong engineering team in both domain knowledge and AI.
On that note, maybe my next question for all of you is, where do you see the biggest challenges then coming in?
It's, if I'm to take this, I think, we're just at the beginning of this wireless AI game, to be honest. And the industry realized it. I'm also part of this organization called the NextG Alliance, which is sort of the 6G technology advisory group that the industry has been putting together, try to guide the federal government and in the industry and academia together to design the 6G technology. So AI is certainly one of the big topics there. But we also identify many of the, like you said, the challenges that we're having right now, right? So like many machine learning-based system, right, you need to make the machine learning algorithm explainable, right? So that you can make sure that when you fail, it doesn't fail spectacularly, right? It might be improving, but if you don't understand it, there might be a problem. The second is for classical algorithm, we can bound the performance, we can understand it, and you test it once, according to the industry standards, run 4 or GCF, if you guys know about this terminology. They will characterize the device performance, and you're done. It's robust. For AI, it's different because you are trying to use machine learning to adapt. You're trying to adapt the neural network in the device. So you need to have a monitoring. You have a new level of monitoring or lifecycle management for this neural network for wireless. It's extremely important. Otherwise, if you just update your model and things break, so that's a big problem, right? So privacy, of course, is another issue, right? You can throw AI at this data, but some of the data has maybe sensitive information in it. It might not be kosher to use some of this data. So there are many generic AI and machine learning issues. The wireless industry, now we're facing it, and we're discussing it. And of course, the core design problem, like I mentioned earlier, some of these like coding, modulation, MIMO, these technologies are actually very well refined already. So we have a chance to improve them. We still have to crack it to show this an order magnitude gain that everyone is expecting, saying, how machine learning can do the magic. So yeah, a lot of hard work ahead of us, but we're very hopeful.
I want to be more specific. I think power is one of the big challenge, especially on the device side. even today, when we add any feature on a device, power consumption is something we're carefully looking at it. And so AI has this reputation of being computationally intensive and power hungry. So how can we enable more AI-driven feature on our device without impact too much on the power is something deserve a full attention from engineers and researchers.
Yeah, maybe I can also add a few experience on how, when we apply the machine learning-based positioning. So yeah, as Tingfang mentioned that for a typical wireless signal processing, you have some input, right? Then you can directly infer what the output will be. But when we use machine learning, even for the testing, for our over-the-air testbed experiment, we have to allocate more time so that we train our neural work with a diverse environment, and then we kind of test our output based on our expectation. So that's, I think, something that we want to keep in mind, how to make the AI more robust. And then the other thing is like we have to keep monitoring whether this model is outdated or not, so whether it's still usable. So those are the challenges which we are facing. And we are actually improving better and better by using the combined, as I said, the domain knowledge from the wireless signal processing, along with the more advanced AI, ML technique.
Yeah, okay. It's quite sophisticated what we have to look at. It's not just getting a lot more data and being able to train the model, understanding what model architecture, but there's many layers to this as we try to deploy it. Maybe I'll end on one more question. What are the things that you're most excited about bringing AI into the future?
Yeah,
we can start with Francis.
I'm excited about a couple of things. As Tingfang and Xiaoxia mentioned before, some of this wireless communication problem is really complicated, lots of moving parts, and it's probably not possible to find the most optimized solution with the legacy approach. So now we have this new AI approach. I'm excited to see the outcome of it and to see how much better it can be. And also as a device-side product manager, I'm excited to have a personalized smartphone device. A smartphone device that can anticipate a person's need, a user's need, and to optimize this user's experience based on his or her habits and routine. Right, a device that can collect environmental information and contextual information to do power optimization and performance improvement. And this is a device I'm looking forward to having. So I do think AI can make the current smartphone device even more smarter than in the future. Yeah.
Cool.
Yeah, maybe since I work on like applying the 5G to vertical. So yeah, my dream is that, okay, with the 5G together with AI, we can truly replace the wire or the Ethernet cable with the wireless connectivity and then have the future based industrial automation.
All right, great. Yeah, maybe share one more thought.
Yeah, I'm
One more
hoping these AI robots can help me design a system. I can lay back and just have a coffee.
Okay, I have
that's not going to happen, but truly, it's,
we need the people with domain knowledge.
it just is. I think the excitement is in the air. So we're feeling it. And as an engineer, there's this just one big toy, a new toy I have in my disposal, and couldn't be more excited to be designing wireless system, with AI. It's my big hammer. Now everything looks like a nail to me. I'm just going to use AI to hammer it.
Awesome. Yeah, and be careful. I guess if you have robots with hammers just going out, you want to get out of Tingfang's way. So with that, I'd like to, I hope you found this interesting. I certainly did. And it's there's a lot of dimensions to bringing AI to 5G. And we had a great panel here to just paint a picture of a few of them. This is quite a lot still behind this. So thank you very much. And thank you for our time.
Thank you. Thank you.